Hi, everyone. Thank you for joining us. Today's presenter is Russell Smyth. He will be discussing the introduction to Zero Trust at Nextiva, so it's a very interesting topic. Russell joined Nextiva a little over 2 years ago. Shortly after joining, he got involved in our efforts to improve our identity and access management processes and systems, incorporating Okta, and he has been primarily involved in IAM efforts at both designing and implementations levels since. Prior to Nextiva, he played almost every software engineering role at one time or another, from engineer to architect and manager. He has several interesting hobbies, riding and repairing bicycles, flying RC planes and quadcopters, 3D printing, and the rather unusual hobby of log sports. Picking locks for a sport. I didn't know that one was a hobby, but sounds interesting too. Before we get started, just want to remind you that if you're interested in presenting, just reach out to the EX team. Remember that you can ask directly add your questions to the chat, and stay tuned because we will do a trivia at the end. So that's it for me. You can take it away, Ross. Thank you. I think you're muted.
That's better.
Yeah, a lot better. Thank you.
So I was just saying, it's been a little while since I've done a big presentation like this, so bear with me if I'm a little rusty. Thank you for the introduction. We'll jump right into what we have to talk about. I did want to make sure I mentioned, because I was asked by a couple of people who reviewed my presentation, what IAM is. IAM is Identity and Access Management, which really encompasses all the things that we do around identifying who our users are and what they're allowed to do. So that's kind of the context of this discussion. Quick overview of the agenda for the discussion. I primarily want to make sure that everybody understands what Zero Trust is and what we are doing to support Zero Trust within the IAM infrastructure. So we're going to have a quick overview of Zero Trust itself, some truths and some misconceptions, try to clarify a few things that you may or may not know. We're going to talk about the tools of Zero Trust that we provide from the IAM team. And then we're going to talk about how you will implement Zero Trust within your applications and services using the tools that IAM provides. So we'll start with an overview of Zero Trust. So what is Zero Trust? Zero Trust is OIDC and OAuth. I'm sure you've heard those terms, right? The truth is that's not Zero Trust. OIDC and OAuth are authentication and authorization protocols that are part of Zero Trust. Proper authentication authorization is absolutely necessary to provide Zero Trust, but they in themselves are not Zero Trust. Another term you have probably heard is JWT or access tokens. So this must be Zero Trust, correct? Absolutely not. Access tokens in the form of JWT as we use them here are definitely building blocks for Zero Trust, but they are not themselves Zero Trust. There we go. Single sign-on. Single sign-on must be what Zero Trust is. No, single sign-on is not what Zero Trust is either. Single sign-on describes an authorization process that reduces the need to continually resubmit credentials, but it isn't Zero Trust by itself and doesn't guarantee Zero Trust. It is an important building block of Zero Trust. So it does kind of bring us to what we've all heard must be Zero Trust, which is Okta. And Okta, of course, is also not Zero Trust. Okta is a vendor we use to implement parts of our authentication authorization process. Primarily, they are the vendor that provides us our external-facing authorization processes and provide us the integration capabilities, but they're not Zero Trust either. They're a vendor that provides parts of it. So you kind of get the idea. These are all tools that contribute to the implementation of Zero Trust, but they're not necessarily Zero Trust itself. So then, what is Zero Trust? This is going to get a little dense. So Zero Trust is a cybersecurity paradigm focused on resource protection and the premise that trust is never granted implicitly, but must be continually evaluated. A Zero Trust architecture is an approach to resource and data security that applies this paradigm. So what does this mean for us? What this means is we trust no one, and we must verify everyone. An important thing to understand is Zero Trust is not a synonym for authentication and authorization. Authentication and authorization are definitely important building blocks to Zero Trust, but they and contributes to zero trust, but they're not equal. They're not the same thing. Some aspects of full zero trust are outside of the scope of what we in the IAM team are doing, not necessarily addressed in the scope of this discussion. I'll try to kind of touch on it briefly, what's outside, but we cover part of what zero trust is. But if you think about what zero trust is, being at absolutely every stage, we're verifying that access should be granted before we grant it. There are definitely other pieces that can come to play besides just identity access management. When we talk about zero trust, it's primarily guided by an NIST publication called Zero Trust Architecture. And one of the important parts of that document is that it lays out the tenets of zero trust. So basically the guiding principles of zero trust. The document documents 7 different principles. There are 3 important principles that we deal with within the space of identity and access management. Those 3 main spaces that we cover are, as stated here, and these are the tenets with how they break down within our space. The first tenet is all data sources and computing services are considered resources. What does that mean? That means that everything must be protected with these zero trust concepts. For Nextiva, that means that every service must validate that the ultimate caller has the required authorization to the data or service being provided. The important part of that is that we don't just grant trust because you've gotten past some previous checkpoint. Each checkpoint, each service must validate that the user is granted that access. The second tenet is all communication is secured regardless of network location. What that means is basically there are no trusted zones. We don't have, once you're inside the network, you're assumed to be trustworthy. We don't grant trust simply because you're within our network. There's always the possibility of someone who's breached our network and has started within the boundaries. We don't want to have leaks through those directions. So the entire enterprise private network is still not considered an implicit trust zone. Everything still must be validated. From our aspect, that just means that every service must act as if an attacker could be present within our enterprise network and must still validate the user, even though they may be 3 or 4 service calls down a chain. The last tenet that directly applies to IAM is all resource authentication and authorization are dynamic and strictly enforced. What this means is every access needs to reevaluate permissions. In the Nextiva space, what that means is we're not going to use the authorization processes we have with our JWT tokens, decode the token once, and then from there down, trust that the access was valid. Each service will have to reevaluate those tokens, make sure that they are valid and still currently valid, and that the authorization permissions that are necessary for that service are still valid for that user and that token. So from here, we'll go on to talk a little bit about the tools for zero trust provided by IAM team at Nextiva. The first tool is user authentication via Okta. And Okta is a third-party vendor that we use to support our IAM processes. They provide out-of-the-box connection for identity federation, multi-factor. They provide the infrastructure that generates our access tokens. They have built into their processes things like key rotation and authorization sessions so that we don't have to build all these things ourselves. It's not our core competency. It's not our primary business. So rather than spending a lot of time, because these are very complex, difficult processes to manage and maintain and constantly evolving. There's constantly new things that need to be integrated. There are constantly new standards and specifications that need to be adopted. Rather than placing a lot of effort into that one space that's not our core business, we essentially outsource that to Okta, and they provide us with these services that allow us to safely and securely authenticate and identify our users, and then also to generate the JWT access tokens that we use as bearer tokens and communication of identity. The next piece is the Nextiva IDP. The Nextiva IDP is essentially the login page is kind of how you can look at it. But what the Nextiva IDP is it's the way we've gathered together our multiple sources of user identity into what looks like to Okta a single user, source of user identity, and provides a consistent single way to access these things. It is built to open standards. It is, while limited, it is a implementation of OIDC and OAuth 2, following the standards for the pieces that are necessary for the integration. It's not a complete OIDC OAuth server, but it does follow the standards for the pieces that it does provide. As I mentioned, it does provide login. It also, for some use cases, provides profile selection. There are some changes that will eventually occur with that, where we'll move that to be part of how Okta provides the services, but currently that helps us with our somewhat unique profile selection process, which most organizations don't have as part of their authorization. It gives us a place to do that for the case where we have to. And eventually this will go away. This should eventually be replaced by entirely Okta solutions. But in the short term, it provides us a way to work around migrating over to more standardized processes. Another tool that we provide is the authorization service. There's actually two that you'll be aware of as you work on services right now. There's the existing authorization service, which is roles, policies, permissions, grading that, or allowing systems to see what users have access to. There is a new authorization service being deployed, actually just hit production a few days ago, and we're working on integrating it into some of the processes that provides a more consistent authorization process, but it also provides a service for the evaluation of permissions, so that permissions are evaluated consistently across applications. We don't have to continually rewrite the authorization logic that's contained within one service, and we can provide some very standardized ways for applications to use those services. So that's the authorization services. As I mentioned, with the new authorization service, there's a built-in ability to evaluate policies. That's what the policy decision service is. This is an endpoint within the new authorization service, and this is simply what gives each service the ability to evaluate permissions without having to rebuild that logic. And it also gives us a way to provide this without having to have a API gateway in front of all of our services that provides the single point of authorization. We still have the way to do that in one place, but have it used by distributed services rather than backing it with a gateway. This service is a very well-defined REST API. And there is a Spring Boot library that we provide that makes it really easy to consume the service for, I'd say, the 90% case. For most general cases, it's fairly simple, and we'll talk about that a little bit when I get to the implementation slides. The next important part is identity and access evaluation via signed JWT. So for people who have been working with some of these services, this is the JWT token, or the bearer access token that you've seen. The value of JWT is they are secure, they are signed, so we can verify that they were issued by Okta as part of our authorization process, and they can carry some limited data within them to reduce round trips and additional service calls for some use cases. They don't completely replace it. They don't carry all the authorization information we need, but it does have the ability to carry some data and help us simplify some of those use cases. We also have libraries available that help integrate this part into your services. And while at least with Java services for right now, Java Spring Boot services, we have kind of easy plug-in, ready-to-go solutions that make this kind of a just happens kind of thing as far as the evaluation of the JWTs and validation that they're valid. Other environments we don't have, so I do have here, what about Golang, et cetera, because we do have things other than Java and Spring Boot. We have talked about this, and we will eventually provide some similar tools for other environments, we hope. However, these are highly standardized processes, so there should be good tools available. In fact, the Spring Boot library itself is really just a configuration of Spring's built-in capabilities. It's not really a library per se. It doesn't bring a whole lot of application code. It is simply a pre-built configuration that you drop a new Spring app, and it uses Spring capabilities. So other languages, other toolkits should be able to consume the JWTs as they are without a big library, but we will eventually probably build libraries to make that even easier. The next piece is service users. So there are limited but important use cases where there is no authenticated user available to authorize a process to. So this can be batch processes. This can be asynchronous completion of requests. For those cases, we provide a capability of service users. So these are users that are used by a service and assigned to a service. So each service has its own user and each of those users has its own permissions, which are limited in scope to just what that service must be able to do. This helps us prevent escalation of permission attacks if someone were to get to a service and use its service user for additional attacks. It's limited in scope to just what that service has to have. We don't create God accounts. That's kind of important that we don't. So when you have a service that has to either initiate, because it's a batch process, what have you, a call, or it's a disconnected service where there isn't a user, we have the service users available for service-to-service calls. And with those, we also have, again, a library, a toolkit, and documentation on how to really quickly add that to Spring Boot applications. And again, other languages we don't have toolkits for yet, but this is a fairly standardized process. Again, even in the Spring case, it really was more of a configuration than an actual development. The only real code we had to develop there was a little bit of a code to adapt the Spring Boot built-ins to REST template, because Spring's unfortunately not supporting REST template as well as we'd like them to, and that's our primary tool. So we did have to add a little code for that. But the general support is kind of built into what Spring does. Excuse me. So to talk a little about implementing Zero Trust. Zero Trust, we talked about some of the steps. This is what we do to implement within Nextiva and our environment. User authentication, as we discussed, is handled by Okta and the Nextiva IDP. So as far as building an application or service as part of the Nextiva stack, user authentication is handled. There's nothing we have to do for this within our applications other than incorporate the tools that we're going to talk about in a little bit for SPAs. Was there a question? Okay. One thing I mentioned here is SPAs that will access protected services. So in other words, eventually all of our UIs will need to obtain access tokens for authenticated users. There is a library that we provide for that as well. And that works with this authentication process to generate those JWTs and make them available for applications to call underlying services with. The rest, I'm going to actually bring up a Confluence page and talk to you through some of the bits that we provide in libraries. I'm going to do it at a fairly high level. I'm not going to actually write code for you, but I have some code snippets to show you, and we'll cover kind of the overview. Let me bring that. And this page is available in our Confluence wiki, and I'll share it at the end of the presentation. So I talked about several different libraries, and we're going to kind of go through what they are here. We'll start kind of from the top to the bottom. The first piece is implementation for our SPAs. It's fairly straightforward. It's essentially a little bit of code that we wrote to work around. Really, we had to work around. Currently, there's a disconnect between what Okta has and what we have because of some security restrictions, because of our UIs being deployed to subdomains, and we have hundreds of thousands of subdomains. The existing Okta capabilities required us to list each and every one of those domains if we wanted to have them all be able to participate in this process. So this tool is primarily to work around that, so that within Okta, we only had to list one. We may actually be able to remove some of this going forward because we've got some new capabilities from Okta, but this is kind of the gist of it. And I'll be honest, I haven't used this directly myself, and I'm not writing UIs right now, so I really can only show you the code and let you know that this is kind of what you would need to do. We add a simple configuration to the project. We include the SSO library. I will say the SSO library is very poorly named because it's really not about single sign-on. It's about obtaining the access tokens and passing them on. But when it was originated, it was kind of part of an existing process. So as much as that's a little confusing, and it's going to go back to what I said earlier about SSO not being zero trust, we'll just kind of have to accept that for now because changing it would just take too much. And as we evolve to some new solutions, we may change some of that naming. But for now, it's called SSO. And then in your application, you actually initialize this, and then these handlers simply have to you take those tokens. And one thing you do need to do as a UI developer is recognize these tokens are essentially keys, and they do give access to services. So we need to make sure that our handling within the UIs is secure. We're not storing these on the file system. We're not storing them in local storage. We're not displaying them to the user. They should be kept in local variables only. And these do need to be passed with all underlying calls. I don't unfortunately have code to show you how that works, but this is kind of the starter. Once we get to here, we can work with you to get you further along on that. And I know we have a few implementations that have used this so far. Within Spring Boot services, making your service able to accept and validate a service token is actually very, very straightforward. We simply have to add a dependency to your Maven POM that brings in the Spring Boot OLF library that we've built. And then there's a configuration that you have to include in your application, which is just an add import. Unfortunately, this formatted badly, but your main application class gets this import added, and that provides most of it. One configuration property that has to go into your application configs will look something like this. And of course, we manage through Spring Clouds. You can have your various authentication servers. These are our token issuers that we have to have configured so that your app knows where to validate the tokens. And that's it as far as making sure that you are getting a valid token and a valid user. That's not authorization. I do want to point that out. We're going to talk about authorization a little further on, but that gives us a valid user with a valid token, and that's kind of where it stops. I'm not going to go into it, but in that same library, we do have a simple plugin configuration to create Swagger docs that will accept a bearer token for authorization so that you can still use Swagger against these authorized services. So that's useful if we need to do testing or need to validate. We can still use Swagger even though the services are authenticated and require bearer tokens. That's what this configuration allows for. Configuring for downstream calls. So the next important part as a service provider is if you're a service that consumes other services, you need to pass the bearer token that was given to you, providing the user's identity, onto the next service so they can also validate the user and check for the user's authorization for their services. That can be fairly complex, but we again have a library that plugs into Spring Boot through simple configuration. And if you're using the Nextiva Spring Boot Maven archetype, this is built into it. But we simply add, and it's the Nextiva request context filter configuration needs to be added, and then REST template has to be added with the request context header interceptor. That will make your application consume the tokens, put them in the request context, and then on any outgoing calls through REST template, we'll include it properly as a bearer token. This makes it basically zero work once you've installed these two libraries. Being part of the zero trust infrastructure, at least from the point of view of consuming and passing bearer tokens, is done. There's no additional work after this for the bearer tokens. Similarly, if you are a service that may be making calls that are not in the context of a user and you need a service user, also a fairly simple configuration, one import, one configuration with your service user's credentials to provide a specialized instance of REST template that's specific for I need to make calls as a service. So one thing I do want to point out is this does need to be a separate REST template than the one that's normally used for user calls. If you are a service that does both in the context of users and out of the context, be careful not to mix them. We don't want to make the downstream calls with the service user if there is a user in context. But this is, again, fairly straightforward and simple configuration to add that to your application. Really nothing here but copy and paste into your application and include the libraries. What does get a little bit more complex is actual authorization. So every service that's taking these calls should be validating that the user has the authorization to do what the service is going to do for them, and every endpoint should also validate this. What that entails is for every request, you have to determine what the resource is that's being accessed, who owns the resource, and who it is that's attempting to access. So if you wanted to do this all yourself, you could extract the user's identity from the bearer token, construct the description of the resource being accessed, make a call to the policy decision service asking for permission or asking if the user has the permissions. It responds with a list of what's been allowed and what's not, and then you can use that to determine what parts of your requests can or cannot be completed. That is a lot of work. What we've done is we've built for the 90% case, some tools within the Spring Boot architecture that allows us to build one configuration that you as a service developer have to build that builds the descriptions of the resources. So you know your resources, you know what the information either coming in or in your data describes the resource. So there is a mapping configuration, and I'm going to bring this up. This is actually all described in the README in the library, which there is a pointer in this document. I'm not going to go too deeply into the configuration because it's a little complex, but basically what you do is you have to go through and say when the resource is one of these, and it's based on your classes in your application or the names of the classes, it's described in this way. So you have to take, if you have, say, a user is the thing that you're accessing, you have to describe that as a user resource in the authorization system, and the owner is, the user, the organization that it belongs to. Build together what that request is. So this is the hardest part of this whole stack, is building this mapping, which allows the authorization service to do its thing. This just maps your concepts to authorization resources and their descriptors. From there, once you've built this configuration, actually protecting endpoints is pretty straightforward. Spring has built in several annotations for security. There's a pre-authorize and a post-filter. Most of the things we'll use pre-authorize, and as you can see here, it's pretty straightforward. So there's no change to the application code itself. Excuse me, it's simply annotations added to the controller methods, or in some cases the service methods. And you simply say has permission, you reference the thing that you want to have access to, and what the action is that you want to allow. This annotation by itself, combined with the configuration that you've built, will generate the request, make the request to the authorization service, decode that request, determine whether or not the user has the ability to access this endpoint, and either allow or disallow the call to complete. In most cases, this pre-authorizes what we'll do. There is in the mapper the functionality if the incoming request has to make additional calls to know whether or not you're allowed to do that. So for instance, if you're going to read a piece of data and the incoming request just has the ID, within the mapping tool is the ability to access the underlying services, make the calls, and use that to build the request. This document's a good place to start, and certainly if you have questions, feel free to contact me or others on the team. We can kind of walk you through how that's done. There is also a post filter, which I don't have an example here. There potentially is the ability to filter results based on security. We've decided not to do that. for this pass just because that's more complex, but you do have a post-authorize. And the reason we use post-authorize in some cases, so as I mentioned with pre-authorize, we can build into the mapper the ability to go call underlying data systems and get the information. In many cases, the call itself will make those calls. So rather than calling the data source, get your data, authorize it, and then having to call it again to return it, we'll go through the process of go ahead and get it, and then before we return it, we'll make sure the user has access to it. So there's a few different ways to apply this. The rest of this document kind of talks about little bits and pieces that have to be put together. It looks kind of dense, but it's really not. It really is build one configuration, add your annotations, and it works. Most of the rest of this document is talking about how to handle a couple of edge cases. We have built into our implementation of has permission some tools to handle the most common cases of collections, collection types, like we have a lot of places we have a collection container that we return, and also handling response entity. Since most of our services currently are being built using response entity in Spring, that's not out of the box with Spring's capabilities, so we've built that into our has permission handler. So that was authorization, downstream calls, service user, we've kind of talked about, kind of all of it. And then the last resource I want to point out before we open up for questions, to go and make this a little bit easier, I did build out an example of an authorized service from start to finish. So this example authorized service repository in Bitbucket is a complete and functional service with authorization, with integration tests, including authorization. So it walks through how to make tests that can test authorized services within the authorization space, make sure authorization is being applied properly. And this repo, I wanted to bring it up, one, to let you know it's there, but also point out how it's meant to be used. In this repo, there is a using this repo markdown document, and this will list the steps. So this repo was committed in carefully constructed steps. That would be, if I start with an empty repo, you can go to the empty repo tag and it's just an empty git repo. The second tag is the archetype result, which is what happens when I just run the Maven archetype, and some minor cleanups. So this would be, I use the Maven archetype, put in my service information and run it, generates this. So with the way we would expect to start a service. It will walk through adding integration tests using the platform test tools, which is really useful and almost going to be a requirement if you're going to get into being able to test authorized services, because we've built some tools around this to make that easier. So adding integration tests through that. The next step that it'll show, and these are all, you can easily diff from a link in the markdown and see what the changes are, so you can see kind of progressively how to build a service up with all these steps. The next step is adding a contract first API. So one of the things we did as we're building authorization and some other the platform services being built around the same time was developing our services by building the open API contracts first and generating our code from them. We found that extremely valuable, extremely useful. It also allows others to start consuming your contracts prior to your service being ready. So if you do want to take this approach, this step shows you how to add all the tools to do that. And again, in a very easy to see diff format, you can see what has to be added, what work has to be done. And it actually has a working service in it. Then we have the actual step of adding authorization. So this next step is adding authorization to the services. It goes through that point of creating the configuration, adding the annotations, and then the couple of supporting libraries. And then lastly, how to add authorization within integration tests within the integration test framework. So you can actually run full, and these integration tests can run fully within test containers on local, or even potentially when we get it set up properly in Jenkins, it'll spin up Docker containers, run your full stack, run your tests. But they can also be run against live instances. So either your local dev or dev QA or even production environments. For authorization, we used our IT tests as our smoke tests and our validation for our prod deployments as well. So, so that's the example service repository. Definitely, if you're working on bringing the service up to authorization standards, take a look at that. And I think, make sure I don't have anything else to talk about here. I think that brings us to the end of what I have to throw at you. And that was a whole lot. I do know that. I think at that point we should be ready to open up for questions. So.
Yeah, we had a couple of questions, Ross, at the chat from Nacho. Matthew was answering them. That's why I didn't interrupt you. But if you want to just take a look to the questions.
Sure. Yeah, for some reason my screen, I couldn't see the chat while I was talking, so I couldn't really.
Yeah, no worries. Yeah, I should have interrupted you, but since he was answering, it was like, okay, I'm not gonna cut out the flow.
Yeah, we have a good team that likes to keep everybody on their toes. So, and Matt is very familiar with most of what I'm working on here. So, so currently, sorry. So you're asking about storing the tokens in the global store, and yes, that is something we have to be aware of. I think Matthew's answer was good. We definitely have to be aware that if it's something that a user can get access to, it is a vulnerability, and script can use that to access services within the context of that user and within a limited time frame, but it is still a potential avenue of attack. Why should that be a security concern if we have the token on each request? So the token that you send on each request is reused for a period of time. They're good for, I think production is currently set for, they're good for 5 minutes. So that is something to be concerned about. If they are taken and used by an attacker, they have about a 5-minute window that they can behave as the user. We do everything by HTTPS, so they should be protected on the wire. It's really if you have the ability for a malicious script to get a hold of that token from within your UI, that's our biggest attack vector.
Interceptor in Axios is adding Nacho to the conversation. Yeah, Prashant is asking us to share the links.
Yep.
And Carlos Lozano has another question. Does our current security implementation plays well with the Spring Access Control List features?
Not really. So we kind of took it from the point of the authorization interceptors, and from there we take on our own because the Spring Access Control lists aren't really built the same way as our authorization process is. We do have a fairly complex capability. With authorization version 3 that's coming out, we've added some dimensions to it and firmed up some of the definitions so that all services can use the same processes and the same patterns for describing access policies to resources. It just doesn't easily slide into the Spring Access Control approach. Hopefully that answers that question.
Nice. And we have another one from Lance Jeffers. If not storing the global UI state Redux, would there be somewhere better to store it?
Nacho answered it.
Oh, yeah, that was the
that's
answer.
Definitely not
nice.
my expertise. And then there was a question about how to authorize with backend service from Kafka consumer. Okay, that's a great question. So the Kafka consumers are exactly one of the use cases for the service users. Each Kafka processor that needs to make additional service calls will need to have a service user, and that service user will have to be authorized for the calls that are necessary. The expectation here, and this is a question that will come up, is, well, we still need to make sure that what's being done by Kafka downstream things is something that's allowed by the user that initiated whatever the call is. If the process is something that is done in the context or is initiated in the context of a user, and the user has to have certain access before that process can complete. That needs to be validated when the Kafka process is started. So before the message is sent, the user's authorization to make that request must be evaluated by the initiating service before the Kafka message is even generated. Once it's been generated, we assume that the launching service has made that validation and that completing the process is valid, and the tail end of that process will pick up the message, do its processing, and use its service user to complete the process. I hope that answers the question. And I will say I don't think we have anything that's actually doing this yet. This is all new, so service users on Kafka consumers probably not implemented anything yet.
And we have another one from Julio, although Ralph just added some comments. Thank you, Ralph.
Actually, Ralph's answer is pretty good. So Julio asks, is there any audit recording for the access request? Is there any logging of the user ID and the requested operation or recording in the database? Currently, there is not. And Ralph has mentioned that he has implemented something within a framework within MP3, but it's not incorporating anywhere else. We can definitely look at that. Like I said, we're just producing the service now. We do have the information available, and there is a trace debug logging that will record every decision, but that's obviously not something we have running in production. It's a really good question, and I think I may actually open a Jira myself to look into what we would like to do along those lines, because we should have some amount of auditing. While we wait to see if anybody else comes up, I also expect that what you will see as we start bringing this into more production use, my expectation is we're going to need to build a few more tools, both for developers and consumers, to evaluate permissions. So if you have a user and they're not getting access to some resource, there may be needs for some tools that allow us to trace, well, we thought they had a permission, why didn't they have access? Because the roles and permissions can get fairly complex. So we don't have them yet, but my expectation is eventually we will have to build some tools that make it easier to draw the line from a user to a resource and determine what does or does not grant access to those resources based on permissions. Looks like we have another question. So for using service user accounts, we would have to prepare the downstream services to not account for the classic Nextiva corp account and profile ID headers, or can we include them dynamically on requests? So if it's a non-zero trust downstream call, you continue to make those pretty much as you always have. That doesn't change. The discussion I had about downstream services was specifically for calling downstream zero trust services. One thing I will mention is my hope is that changes quickly to where everything is zero trust. That's kind of the point. In fact, we're not at zero trust until all of our services have incorporated this. So we should be changing that quickly. We've got a few teams that have made some of these changes, so we kind of know what it incorporates or what it takes. The first pass of getting the authorization tokens passing through is kind of the first piece, and then that also then provides the ability to do the more finer grain and stronger controlled authorization through the authorization tools. And Ralph's answer, for those who aren't reading, expands on what I was saying. Everything requires a valid request context. So the tools, if you implement the tools as described in the documents that I was showing, it will make sure that the request context is populated properly and is forwarded along. So if you're a service that's consuming as zero trust with the authorization token, the request context should be built out properly so that when you are making a downstream call to a non-zero trust service, it still gets the proper request context and header set for those calls to perform properly.
Is there any other question, team? We still have a couple of minutes. No?
I very much expect that there will be questions after the fact. there's a lot of information here, and reading through it, I'm sure more questions will come up. Please feel free to reach out to me or anybody on the team, really. At least we'll be able to direct you in the right direction. And certainly as questions come up, I will try to add to the documentation and build on it. I hope that's been valuable. The one thing I will say is authorization is really, really difficult. When I was adding the authorization to the authorization service itself, I felt the pain, and I did everything I could to make that pain less painful. But it's not a simple process. Authorization, because of the nature of security, does require some work. Where we can, we'll make it easier, but just be prepared. The first one's going to hurt. It'll get easier as we get into it. The team, I was asked who the team is. It's myself, Matt Like, Manish Kunt, I remember who else is on my team. Pratish Goswami, and Wenming Cao, and Kevin Hale. I think I got everybody. It is the What Me Worry team, and we do have I think they're still on open What Me Worry Slack. May or may not, but certainly reach out to any of us.
Thank you, Ross. This was great. Thank you for doing this. I think it was a very interesting topic, and we hope that we will have the volume 2 at some point.
Absolutely.
Awesome. Thanks, everyone, for joining.